Hi, welcome to Unit 6B, Day 4. We're going to mix up those trig applications where sometimes we're looking for a side and sometimes we're looking for an angle. So you need to remember which method you're going to use to solve. If we're wanting to find a side, we're going to set up our trig function as a proportion, then cross multiply to solve. If we want to find an angle, that's when we're going to use the inverse trig function. So what I like to do is just try to remember that I'm looking for a side. That means I'm going to cross multiply. And when I'm looking for an angle, actually let me do that one in a different color. When I'm looking for an angle, that's when I'm going to inverse. Okay, so side, cross, angle, inverse is what I'm going to try to kind of remember, okay, as I'm going through. Now I do know that I'm going to be using the calculator to do these problems, and I know I'm going to be using the trig function on the calculator, so I don't like the one that comes with my phone when I'm doing that, so I like to use the one that I'm going to have access to when I take the test. So I want to use that CMS one, which I already have open here. Again, if you're struggling to get it open, make sure you go to your sync time and check with your teacher, whether that's me or Miss Barner or Miss Ash or Miss Sue, and find out how to open that calculator and how to work that calculator because it's super important. Okay, and remember, I make my window so it hugs that calculator, and then I like to set both my screens where they can be seen side by side. Okay, and then I'm going to take this calculator and check the mode because remember we are working with degrees on our angle. So I'm going to hit mode, and if I just turn this calculator on, it's not going to be in degree mode. It's going to be in what's called radian mode. So I'm going to arrow down and over and then hit the enter key so that highlighting moves from radian over to degree. And then I'm going to click on second mode so that it gets me back to my calculator screen. Okay. All right, so let's look at these problems. My first one says a regular polygon is a polygon with congruent sides and angles. So we've learned about polygons way back in elementary school and middle school, just our basic flat shapes that are closed and made with segments. Okay, so we know what polygons are, but now we have this new word regular, and that just means it has congruent angles and sides. So think square. A square is a regular polygon because it has 4 equal sides and 4 90-degree angles. Think about an equilateral triangle because all 3 sides are the same. All 3 angles are 60, so that's a regular polygon. Okay, and then we have this other vocabulary word. So 2 just extra vocabulary words for today. It says the apothem is the distance from the center of that regular polygon to the side. And your apothem will always intersect the midpoint of the sides of that regular polygon. Okay? So then I have this question. It says stop signs are generally regular octagons. So when it says regular, that means it's a regular polygon. So all my sides are the same length, all my angles are the same measure. Okay? And it says that they have a side length of 34 inches. So you know what? I'm just going to mark that on here. I'm going to say my side length here is 34 inches. So 34, 34. I know these are all 34 because my stop sign is a regular octagon. So there's 8 sides that are all 34. We could put inches here if we wanted to. Okay. It says, what is the apothem of a typical stop sign? So we're going to have to figure out if we can figure out how to apply trig SOHCAHTOA to this figure, which means we need a right angle, okay, because we need a right triangle. So I know that these corners, they look like they're going to be too wide to be right angles, so making a triangle out of a whole corner here isn't necessarily going to help. But this apothem that has been drawn in, since it is the distance from the center to the side, I know that that means distance is measured perpendicularly. So from the center of this figure to the side where it intersects, I know that since it's a distance, it hits at a 90-degree angle. Okay, so I have a right angle right there, and I could sketch myself in a little hypotenuse and make myself a right triangle here. Okay, so now I have a right triangle here. And I'm looking for this apothem. I'm looking for this length here. I need to know an angle and I need to know a side in order to use trig. We need the acute angle and we need one side so that we can find the other side. Okay? All right, so I know this whole side here is 34, and it tells me here the apothem intersects the midpoint of a side. So if this is a midpoint, both of these pieces are the same. If all the way across is 34, then I can do 34 and divide that in half and see that each of these sides are going to be 17. Okay, so now I know one side. I know I'm looking for this apothem. I need to find an angle. So I either need to find this acute angle or I need to find the one up here at the top. So look how I'm going to do this. I'm going to think about if I were to draw in all the apothems here and here and here and here. If I draw them all in, since it's a regular polygon, all my sides and shapes and everything are the same. And then I draw in to the corners, and believe it or not, that's called a radius, even though this isn't a circle. To the corners, that's called a radius. To the corner, to the corner. If I was able to, with my mouse, draw straight lines, we would see that this is going to make triangles that are all the same, because all these apothems are all the same length. Okay, all of these angles here are going to be 90, right? All of these radii are going to be the same length, and all of these are going to be 17. So by side, 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 or by side, angle, side, all of these angles are the same. Okay, I know all the way around a circle is 360 degrees. So how many did I make? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, which makes sense because each side I can see I made 2 triangles, right? On each side I made 2 triangles. And if there's 8 sides, I can see that means I made 16 triangles. Okay? All the way around this circle here is 360 degrees. So if I take that 360 degrees and I divide that into 16 little angles, let's see how big each angle is. So 360 divided by 16, each of those angles is 22.5. So that means this angle right here is 22.5. I don't know if I can write that in here small enough. Let's see, 22.5. Nope, that doesn't look like 22.5. Let's try that again. Give myself a real thin line. 22.5. There we go. That's better. All right, so now I know how big that angle is. If I look at that triangle that I have there, I'm going to erase all this extra stuff that I don't need anymore. All my little dots. If I can get them all. There we go. I don't need those little bits anymore. Okay, so now we've drawn ourselves a triangle. And I know I'm looking for one side, and I know the angle there, and I know one of the other sides. So I'm going to apply my trig patterns. So to do that, I need to figure out what angle I'm at. We always start at an acute angle. And again, I found that angle by taking the whole all the way around that center and dividing it by 16 because there's 8 sides. And on each side, I made 2 triangles, right? So divided by 16. If I had 7 sides, I would divide by 14. If it was a hexagon, I had 6 sides, I would divide by 12. Okay, so that's how I found that angle to be 22.5. That's my smiley face, which means coming out of that angle is my hypotenuse on one side across from the 90 and my adjacent on the other side, which is kind of nice because it's already got an A there, right? And then across from that, remember this smiley face reaches for the remote on the opposite side of the room. So that's my opposite side. I'm going to compare this to so, ka, toa, so that I can figure out which trig function I want to use. All right, let's see. I know the opposite side is 17. And I'm looking for the apothem, which is the adjacent side. So the trig function that has 2 is tangent. So tangent of the angle, 22.5, equals O over A. O is opposite, A is adjacent. O is opposite, 17. A is adjacent, which is the apothem, A. Okay, so this time I'm looking for a side. So I know up here if I'm looking for a side, I'm going to cross multiply, which means I need to make this into a fraction by setting this side over 1 so that I can cross multiply. A times the tangent of 22.5 is going to equal 17 times 1. So I'm going to start with the A times the tangent of 22.5 equals 17 times 1. And notice I don't have A equals, I have A times. So I need to untimes, I need to do the inverse of multiplication, which is division. Remember, inverse just means like the opposite, the undoer of it. So the undoer of multiplication is the division, tangent of 22.5. If I divide on one side, I must also divide on the other. So I'm going to end up with my apothem is equal to this 17 divided by 22.5. 17 divided by 22.5. Oops, not 22.5, right? If I do that, I'm missing something, right? I'm missing the fact that this is the tangent of 22.5. 17 divided by the tangent of 22.5. I close my parentheses because I always want to put that seatbelt on, and I get an answer of 41.041. And we do have units on this, right? Because this 17 came from 34 inches, so 41 inches is how far it is from the middle of that stop sign to the edge of that stop sign. If the side of that stop sign is 34 inches. Stop signs are much bigger than you think they are when you look at like a major intersection stop sign. Okay, 41.041 inches just to the center of that stop sign. Okay, now look at my next question. My next question says use the apothem to find the total distance across the stop sign. So if I want all the way across the stop sign, that means from where the apothem ended, I need to do the opposite side than another apothem. Well, what's nice about the regularness of the polygon is that the two apothems are going to be exactly the same. So if this one's 41.041, then this one's also 41.041. So that means I just have two of those 41.041s. All the way across, I'm just going to come over here and hit times. Notice I didn't type that in. I just went straight to hitting times, and it's saying, oh, you want me to multiply to that last answer. Because remember, I rounded that last answer. Oh, and I didn't even round it correctly, right? Because after that 1 is a 6. So this actually should be a 2 there if I'm rounding correctly, which we do want to round correctly. Okay. All right. So when I multiply by 2, I get 82.083 inches. So that's how far it is all the way across that stop sign. Okay. Hopefully that helped with that one. We have more examples that we're going to do, but this video is already a little on the long side, so come on back for this next video. We're going to look at a submarine at the surface of the ocean making an emergency dive. Okay, so we're going to sketch that picture to figure out how many meters the submarine is going to travel along its path. All right, thank you so much for watching. Come on back for the next video.